Okay, so this is chapter review for equation writing and stoichiometry. Okay, like I said, this will be a fairly easy test relative to the one on February 7th. Clear?
Yes.
There'll be several matching sections, definitions. Okay, so you need to know things like reactants are on the left, products are on the right. That arrow means yield. So reactants yield products. This is a chemical equation. Okay, you have a skeleton equation, which is unbalanced. You can have a word equation, which is hydrogen plus oxygen yields water in those words. That's a word equation. You can also have a balanced equation. We know that a complete balanced formula, nomenclature formulas, a complete balanced formula equation is also known as a stoichiometric equation. You have to be able to work with the activity series of metals, and that includes hydrogen. And I gave you an activity series in the handout on equation writing that reviews the different types of equation writing. And we'll do a couple problems with the activity series for the review. Okay, we have different kinds of reactions. Combustion reaction, single replacement, double replacement, decomposition, and combination. I call it a synthesis reaction, but they're also known as combination reaction. You need to know what actual yield is. If you're doing an experiment and you're producing a chemical, you're producing, you're producing magnesium chloride. Clear? I left this unbalanced, okay? To balance this, you need to do this with a coefficient. When you balance an equation, you can only use coefficients. Let's say that theoretical yield, let's say, based on the chemicals that I'm using for the reactants are on the left, the reactants. Let's say, theoretically, I should produce 20 grams of magnesium chloride, but instead, I produce 15 grams. Is that on there? Is that too low? What I just wrote on the board, is it on the?
It's on.
Is there? So this is the theoretical. That's what it should be. That's what it should be. Theoretically, based on the amounts of magnesium and hydrochloric acid I've been given, I should theoretically get 20 grams as an example. But I only get 15 grams. I call that either experimental yield, or this book calls it an actual yield. The amount that I get, the actual yield, divided by the theoretical yield times 100 is the percent yield. So I have actual yield is what I get experimentally. The percent yield is the actual yield divided by the theoretical yield times 100. And let's say I used plenty of magnesium, more than enough. But I used just enough hydrochloric acid. Then I would say that this was excess and this was limited. Clear? Now, there's a test you can do to determine what's limiting and what is in excess, and we'll do a couple of problems on the next review video. Okay. Now, so you need to know what limiting reagent is and excess. You have to know definition. What is it? Not just how to get it. You need to know the mass and the volume. What is the mass? If I'm doing a problem and I start with a certain mass of magnesium, and I want to calculate, well, what mass of hydrogen will I obtain? That's a mass problem. I'm given a mass and I need to determine a mass. If I'm given a certain volume at STP of, let's say I have this. Let's say I have this. Let's say I have nitrogen plus hydrogen yields ammonia. And I'm given a certain volume of this gas. Yes? What volume of that gas do I need? And what volume of gas will I produce? That's a volume problem. Clear? It's all based on the number of moles. So volume, this volume does not have to equal that volume. This number of moles doesn't have to equal this number of moles. This total mass, though, has to equal that total mass. Clear? It's conservation of mass. The law of the conservation of mass. Volume in moles may not be conserved. That's okay, as long as the masses are conserved. Clear? So, what do I mean here? Number of molecules and moles. Well, when I write this equation, hydrogen plus oxygen yields water. I can look at this. This is a stoichiometric equation. It's a balanced equation. Where did I get the word balance? Balanced equation, right? So I can look at this and say, I'm going to have 2 molecules of this and 1 molecule of that. And I'm going to produce 2 molecules of that, correct? Or I could say, I'm going to have 200 molecules of this. That'll be 100 molecules of this, 200 molecules of this. This will be 2 billion molecules of this, 1 billion, 2 billion. Or 2 moles of this, and 1 mole of this, and 2 moles of this. So you can use molecule or mole to describe a stoichiometric equation. This is 2 moles of this, sorry, 1 mole of this. Sorry, this is not balanced. This is 1 mole of this, 3 moles of this, and 2 moles of this. Or 1 molecule, 3 molecules, 2 molecules. So you can either use the word molecule or formula unit or mole to describe how chemicals are related in a chemical equation, a balanced chemical equation. Okay, so we'll do another one over there. I got notes on the board, and we'll just simply move over there. Clear? We're off.